Hello and welcome to today's lesson on Ohm's law, which is part of the electricity topic in GCSE Combined Science Physics. So in today's lesson we're going to look at calculating and defining what resistance is. Now if we're successful and we learn in today's lesson, we should be able to understand the basic definition of resistance, construct an electrical circuit and measure electrical quantities in that circuit, and define and use Ohm's law to calculate resistance, which falls into the following part of the GCSE specification: current, resistance and potential difference, and resistors. Now, when free electrons or any other charged particles move around a circuit, they hit into the metal ions of the wire and each other. This slows the free electrons down and lowers the current, and we call this effect resistance. So the metal wires also have metal atoms in the wire as well as electrons. So when the electrons collide with the metal ions or atoms, the electrons slow down. This lowering of the current is electrical resistance. Now, the more blocking of the free electrons moving, the more the resistance. Now there are many ways to do this, like increasing the number of metal ions, making the metal ions vibrate more, or decreasing the space between the metal ions. So when electrons move to create a current, they have to push their way past lots of vibrating ions which make up the wire. The ions resist the electrons moving as they collide with them. This is resistance, and resistance is measured in ohms. Now previously we've looked at what resistance is and how we can change resistance. Now we're going to look at how to calculate resistance in an electrical circuit, and this was first found by the famous physicist George Ohm, and so is called Ohm's law. So George Ohm realized what the concept of resistance was. Resistance is the difficulty charged particles have when they try to flow in a current, and resistance is caused by the collisions between the charged particles and the metal ions in an electrical wire. Now we can calculate resistance with the following equation. Resistance is equal to potential difference divided by current, and we name the unit of resistance after George Ohm, and therefore it's measured in ohms. Now when an object has a constant resistance, we say current and potential difference are directly proportional to each other. Now directly proportional means that the two factors change with the same rate, so when one doubles, the other doubles, and when we observe this happening, we say the device obeys Ohm's law. We call the component an ohmic component. Now constant resistance can only be achieved when a constant temperature has been maintained on the material, as temperature affects how many collisions occur every second. Now Ohm's law therefore can only be achieved if a device has a constant temperature. So we can calculate resistance with Ohm's law, and Ohm's law is only true when the temperature of a wire is constant. So resistance in ohms is equal to potential difference in volts divided by current in amps. Now any component which follows Ohm's law is called an ohmic component. So let's look at an example calculation. A 10-volt bulb has 2.0 amps of current going through it. What is the resistance of the bulb? Now you should try and give your answers to the correct number of significant figures with units on your answer. So we know resistance is potential difference over current, so it's going to be 10 volts divided by 2 amps, so it equals to 5.0 ohms. 5.0 because the 10 volts is two significant figures, 2.0 is two significant figures, so your answer is given to two significant figures, and we give it in ohms because that's the unit of resistance. Now we can calculate resistance experimentally with the following method. So step 1, you place an ammeter in series with the object, and that's used to measure the current through the resistor. Step 2, a voltmeter is used to measure the potential difference across the object. Step 3, the variable resistor in a circuit is then used to adjust potential difference and current. You investigate the variation of current with potential difference, and the variable resistor is adjusted in predetermined steps. Then in step 4, at each step, the current and potential difference are recorded from the voltmeter and the ammeter respectively, and the measurements are plotted on the graph. And the measurements of potential difference and current can give the following graph. Now when you put potential difference or voltage on the y-axis and current on the x-axis, axis, the gradient of this line is the resistance of the circuit. Now it must have a y-intercept of 0 or go through the origin, as without a potential difference there is no current. Now a straight line through the origin shows a directly proportional relationship. So in this instance, current and potential difference are directly proportional. So if the line is not straight and does not go through the origin, then the material does not follow Ohm's law. Now, we can work out the resistance of a resistor from a graph. Now, if you put potential difference of voltage on the y and current on the x as mentioned before, you will get the gradient of the line, how steep the line is, to be the resistance. So the higher the gradient of the line, the higher the resistance. The lower the gradient of the line, the lower the resistance. And a straight line gives a constant gradient, so the resistance of the material is constant. Now, we measure current with an ammeter. An ammeter is a measuring device with theoretically no resistance and is placed in series in a circuit, and we measure potential difference with a voltmeter. Now a voltmeter is a measuring device with theoretically infinite resistance and is placed in parallel with the device being measured, so VIP, voltmeter in parallel. So here's an example of an ammeter placed in series, as you can see in these particular circuit diagrams. Now an ammeter is placed in series because it allows to measure the flow of the electrons. Now think about it, only one point is needed in a circuit to measure how quickly the electrons are flowing. So this means ammeters can be placed in a circuit in a series formation. Now ammeters also have a low resistance, as this doesn't affect the current flowing which it is measuring. Now, a voltmeter is placed in parallel in an electrical circuit, as shown in this particular circuit diagram. Now the voltmeter measures the energy difference but over 2 points of the circuit per charge, so it needs to be in parallel because it's measuring the difference of energy before the device and after the device per charge. This means voltmeters need to be placed in a parallel formation, and the voltmeter is placed in parallel with the device, not any other part of the circuit. So if you were measuring the potential difference of a battery, the voltmeter needs to be in parallel with the battery, not any other part of the circuit. Now as the voltmeter is placed in parallel with the device, it has a high resistance, so it doesn't affect the current flow of the circuit, because if the voltmeter has a high resistance, well then none of the electrons will flow through the voltmeter, so it will not affect the value of current in your circuit. So what have we learned in today's lesson? The current through a component depends on both the resistance of the component and the potential difference across the component. The greater the resistance of the component, the smaller the current for a given potential difference across the component. And we know potential difference is equal to current times by resistance, or as we looked at in today's lesson, resistance is equal to potential difference over current. And you should be able to explain that for some resistors, the value of R, resistance, remains constant, but in others it can change as the current changes. Now the current through an ohmic conductor at a constant temperature is directly proportional to the potential difference across the conductor. This means the resistance remains constant as the current changes, and you get the following graph, a straight line through the origin. So if we've been successful and learnt in today's lesson, we should be able to understand the basic definition of resistance, construct an electrical circuit and measure electrical quantities, and define and use Ohm's law to calculate resistance. I hope you've enjoyed today's lesson looking at Ohm's law, which is part of the electricity topic in GCSE Combined Science. Thank you very much for listening and have a lovely day.